In the lab section, we will have two labs. The first one will be router, another one. It will be a very simple lab with only two routers and two computers. This means expressing two different networks connected together using Ospf. This is similar to the static route lab. So let this be this way, this way, this way. Please expand to here, and this one expand to here, so that the interfaces names are clear. Okay, so the networks will be with some private networks. It will be 192.168.1.0/24 for this network, and let it be, please come here, another sticker for 192.168.2.0/24, and finally between the routers let it be 10.10.10.0/ a point-to-point, just like not waste a lot of IP addresses for between these two, because we know it's already a point-to-point. So start with the first device. You know how to configure the initial config right now before starting to Ospf. Let it be .10/24 and back to the gateway of .1. This means that fast Ethernet 00 must be .1.1. So CLI for fast Ethernet 0.0. Start the config, enable, configure terminal, interface fast Ethernet 0/0. It will have the IP address of 192.168.1.1. Okay, with no shutdown command. Up arrow 3 times, fast Ethernet 0.1. IP address 10.10.10.1, since it's the first router. Don't forget about 252, which is the subnet mask of /30, the point-to-point. Only the link is up, waiting for the protocol. Okay, so exit again, and show IP interface brief, please, thank you. Okay, so this is for R1. For R2, the same thing, it's only the initial config, should not be confused about something. Enable, configure terminal, interface fast Ethernet 0/0, IP add 310.2 and /30. No shutdown, should make everything comes up between them now. Good. And sir, please configure 0/1 to have the IP address of .2.1, which will be the gateway of this last PC there, and finally this PC here will have 192.168.2.10, because it's a PC. Okay, I'm sorry, go back up, go tab again, just make it automatic. .1, we are good to go for local area networks between us, like ping my gateway, and there is a reply, which is good. Please ping the other side. You can ping from the privilege 10.10.10.2. Okay, and the first one is lost, the others are received. 4 out of 5 received, which is 80%, and these the statistics of the ping command. Okay, so now we will start the Ospf process. You'll see it's very simple. It's a single or two commands, but without teaching manually or routing manually. Okay, what will happen is that this router has two arms, has two links. One of them is connected to this network, the other is connected to this network. What I will do is that I will advertise these two networks inside Ospf, and after that hit exit. That's it. How will this be accomplished? Configure terminal, how to get inside the hierarchy configuration of Ospf, you will type router Ospf something mandatory, which is the process ID. It's a random number, must match on both sides, but it's a random number, take from 1 up to 65,535. Of course, we will take number 1 for easy. I will first advertise the first network, which is 192.168.1.0 space. I must give the subnet mask, but I will stop everything now and I will talk for 2 minutes about something called the wild card mask. I should have mentioned it in the slides, but let's talk about it here. We will need it only in the practical side. The wildcard mask is the opposite numerical value of the subnet mask. Don't worry. You remember the subnet mask is a series of ones followed by a series of zeros, and there will be no ones again. So you will see big number, after that big number, after that a big number, and after that a smaller number. You will never see big, small, and again a big. Once it gets small number, then it will continue to become or to be smaller or the same small number. So this is the subnet mask, the normal subnet mask that you know. The wildcard mask is a series of zeros followed by a series of ones. This is the opposite, but not followed again by a series of zeros, just like the subnet mask. What a wildcard mask is, just to have a simple formula to get the wildcard mask out of the subnet mask that you already know. This is the formula. Okay, 255 minus the first value of the subnet mask dot 255 minus the second value dot 255 minus the third value, finally 255 minus the fourth value of your subnet mask. So in my case, let's borrow the blue pen. Okay, so in my case, my subnet mask for /24 is 255.255.255.0. This one I will place it in here, 255. The second one should be in here. The third one should be in here. And the fourth one should be in here. The result of this formula is my wildcard mask for a network that has /24. So 255 minus 255 is 0. This one also 0. This one also 0. And finally 255 minus 0 is 255. So my wildcard mask for /24 equals 0.0.0.255. As simple as that. That's it. So I will type it just in here instead of typing the subnet mask, because this is how Ospf and the IGRP understands subnet masks, by typing the wildcard mask. This is its algorithm. Okay, so this is for /24, and for /30 that it's hiding behind this window, it will be, just take your notes. I'm going to erase all of this, go back to my red pen. Okay, my formula was 255 minus the first number dot 255 minus the second, 255 minus the third, and 255 minus the fourth. For /30, the subnet mask is written this way, if you remember, 252. So the result will be, the dark blue is better. Okay, the result will be this one in here, this one in here, this one the third, this one the fourth. It will be 0.0.0.255 minus 252 is 3. This is the wildcard mask to advertise a subnet that has /30. Okay, so this is all the big deal of wildcard mask, and that's it. Listen, if this was clear, then we will go back to the lab. If it wasn't, pause the lab, comment down below in the video to have any further explanation about the wildcard mask. Okay, so back to my lab, I will type the wildcard mask that we have just obtained for a subnet that has /24. This is, oh, I have remembered forgot something, which is the area. At which area does this network that you are advertising relies? In the new Ccna, we will configure an entire network inside area 0. Okay, inside area 0. So take this one off and go back. So I will type in here area 0, hit enter, and I have just advertised this network. The second thing to advertise is the other network that is connected to me. This will be network 10.10.10.0 with the wildcard mask .3, and of course under the same area so they can communicate together. And that's it. I'm done. I have finished Ospf. I have done everything in here. Thank you. And I will go to the other router. On the other router, I will be configure terminal router Ospf1 network. The first network will be the 192.168.2.0 with the wildcard mask of 255 because /24 area 0. The other network would be this one that is common between them, and this is what will make everything goes correct now. .3 also area 0, enter, and let's wait for the loading and database description to be completed. Yes, now I had received a message. It's an Ospf message. It's an adjacency change message. In process ID 1, neighbor happened with 192.168.1.1 on fast Ethernet 00. It was loading. Now it's become full because loading is done. Okay, so now I'm done. Now I can verify my lab. Good. Okay, it will be verified by pinging or trying to reach the remote PC, which has the IP address of 192.168.2.10. Maybe the first one will be lost because negotiation is not completed yet between all the network. The other one is received, as well as the third, fourth, repeated. All of them will be received, and that's it. Okay, so this is implementing, configuring Ospf to verify it. The first step was to verify it using the ping. The other things will be some show commands, like the first one is like static route, which will be show IP route, just to check how we are reaching the remote PC by using O. This router has two connected things, which are both of them are C, which is connected, no problem, but O stands here for, where are you, the Ospf. Okay, using Ospf I can reach this network that has this subnet mask. The administrative distance is 110. Fast Ethernet will give you the cost of 2. Okay, using this next hop and using this link. Okay, so this is the first verification command. The other one between routers will be show IP Ospf neighbor. This will tell you that I have a neighbor with an ID, a router ID, which is this one that has this ID. I haven't configured the router ID on R2. Where did this number came from? It came from automatically by choosing the biggest or the highest configured IP address inside the router. I have configured only 2 IP addresses here, which was 10.10.10.2 and 192.168.2.1. okay, inside them, which one is the bigger? Clearly it's this one, so this one is chosen as the neighbor RID. Okay, the state is full and it's chosen as BDR. This is no problem because it's already a point to point, and the address that I'm connected to is this one, using this fast Ethernet. Okay, so this is, you see the router ID. in the show IP Ospf neighbor. Finally, I have show IP Ospf database. Okay, now I have area 0, a router link state, and network link state. These are two types of LSAs. This will give you some detailed information about the LSAs that are exchanging between the two routers. Okay, you may not make use of it in the Ccna, but you must know the command and the result of it. So this is all the verification that you will need after implementing and configuring this lab. This is a very simple lab. In the upcoming video, we'll have a complicated lab, much more routers, some cases, how cost will work, how the metric will work, and of course we will use not only routers, you will see other devices. Okay, so I hope all of this was informative for you. For anything, please comment below in the videos. Also, it will be generous from you to like and subscribe our channel to follow all the course up to the end, before the end of the upcoming February. Okay, thank you very much for watching, and we'll see you in the upcoming video. Goodbye.